This is so that when you print the PLA, it fits tightly. So you actually need to be a little bit bigger than the bit you cut into the wood, because you want this thing to compress and hold in there so you don't have to glue in all your frets. So this is just this is only 3/10 of a millimeter, but it's enough that you can still get it in with a little bit of pressure. It's just a quick glance at my open source fretboard creator that I provide in other videos. I'm not going to go into all the details, but if you've never set this up, you want to get this program, type it in, and then you can generate frets very, very quickly based upon whatever parameters you want to put, and you can slide these back and forth. 3-inch scale fretboard, a 1.5-inch diameter fretboard. My SVG, I go over to File, I go to Export, and we export it as an SVG. Now in my VCarve software, I've got it set for poster board. I'm going to go ahead and do it this way for the moment. And so I'm going to just click, put the datum in the far bottom corner, click OK. I'm going to import my SVG, and there's my fretboard I just created. You don't see it here because it's actually below. So if you just, it's already all selected. So if you just hit your arrow key up, you can bring it up here. And you do want to put it in the bottom right hand corner here, like so. So you've got that. I'm going to click on this outside line. I'm going to hit delete. And if you note at the top, it's actually got a spot where the scale length stops. I'm going to go ahead and delete that off. And now I'm ready to CNC this. If you don't want the fret marker CNC'd, then you can just go along here and you can click on these. So I'm just going to take these off for the moment. Go over to tool paths. We're going to do a line on tool path. So it's just a profile tool path. We want an 1/8 inch end mill. The depth of cut that we're going to do is going to be 2 millimeters, and 40% step over is fine. Whatever feed rate is appropriate for your machine. And so I'm just going to go ahead and select my vectors, calculate, and when I do, I preview this. There we go, we got our slots cut. So step one is you want to trace your patterns on a piece of poster board that you've anchored down firmly. This is a scenario where I don't use magnets to hold my poster board down, but I actually screw it directly to my spoil board so it's firmly anchored, because I'm going to be mounting the fretboard material, the fretboard species, directly on top and machining them, and I don't want them to shift when I screw the fretboards down. Once you've got where you want to put your screws, and you know you're not going to be cutting a fret across where you put your screw down to screw down your fretboard material, you're going to shift it so that it perfectly lines over these frets that you've drawn for whatever scale pattern that you have. And you want to have it so that the top and bottom has no markings whatsoever, because the frets are exactly as wide as your material here. And then we're going to carefully anchor this down. And if you look at the side, I don't see any areas where it's bowed up. That would be another thing. If there's any areas that's bowed up, then what you would have to do so that our fret depth is uniform throughout is you'd have to put in a little hold piece on the side here to pin it down so that it wouldn't be bowed up. So make sure that it's nice and flat with the surface too. I wrote, this is also an OpenSCAD. It's a small program that will let you to customize the size of any frets. It'll put a round over on your frets so that you don't have to hand file them, and it will allow you to set the depth and the width of your fret, as well as the length here. And it's all customizable. If you're going to machine out of a neck width of 1.5, like I showed you in the V-carve, the SVG I created earlier, this is your setup. It's got all the parameters set. When this is set up to print with white hatchbox PLA, and it will friction fit very, very tightly, so you don't have to glue in your frets, which is really nice. So these are the parameters that I used on this, and I'll just quickly scroll down, but you could type this program in and you can save it, and I'll show you what it's capable of doing here in a second. So it's not a very big program. It's only got it looks like 37 lines in it, and so with it you can do everything. So if there's the first 18 lines, and these have set all the parameters that we can vary. Whenever you see one of these comments with, you go, why would I do 25.4 times 1 in this scenario? If I put a formula inside a parameter like this, then it will keep it out of the customizer. And since this is a constant inch to millimeter conversion, I don't want that to show up, because it'll mess up your whole program if you were to tamper with that. So something like this number of faces, typically people aren't going to be changing that. So if I want to keep it out of the customizer, it's a trick you can do, is you can put a formula, and if you multiply the number that you really want to stay constant times 1, then suddenly it doesn't appear in the customizer window. So that means somebody's not going to mess it up with the slider. They're going to have to go deliberately in here and change the code. So here's the first 18 lines of code. Let me go ahead and scoot up to line 19 over here. And here's the next section of your code that you can type in. And then finally, I'll go. Here's 29 to 37. So 37 lines of code, and you've got a customizable fret maker. This is the width of your fretboard. If you're using an 1/8 inch bit, which is what I would recommend when you cut these frets, this is what you're going to use. This is so that when you print the PLA, it fits tightly. So you actually need to be a little bit bigger than the bit you cut into the wood, because you want this thing to compress and hold in there so you don't have to glue in all your frets. So this is just this is only 3/10 of a millimeter, but it's enough that you can still get it in with a little bit of pressure, but you won't have to glue in your frets, which is really, really nice. And you can just press them in by hand, which is the thing. If you change the PLA type to a different color, you may have to adjust this up or down a little bit, because I found that even with the same brands, if you change the color, sometimes you have to micro adjust this. So this is micro adjustment. If it's too tight, you can lower this value down. If it's too loose, you can raise it up. But for hatchbox white PLA, this is what I found works. This is the depth of your slot that you're cutting into your PLA, and you'll notice that also I put just a hair extra, 2/10 of a millimeter extra depth from here to this top flat part right here, even though supposedly the depth that we're cutting is only supposed to be 2 millimeters. When you press this thing in, I think there's a little bit of shrinkage in the PLA when you print it, and so that should make it flush. But if you want to adjust up or down, you can. The round over determines how high your little fret here is going to be. The nice thing about putting a cylinder across is, of course, there's a single point here, which is what you really want for your lines. The number of frets, I would recommend the first one you print once you cut your slots in your fretboard is just do 1. Make sure it fits tight. If not, you're going to adjust this fret tolerance until you get a good fit, and then you can upscale this. So let's say we wanted to do the copies of frets here. Say I wanted my number of frets to be like 3. I wouldn't recommend printing too many all at once, but if I hit F6, you're going to see that The STL that we're going to generate now has 3 sets, so that when I go in my 3D printer, I can print them in sets of 3, and it's much more efficient. I don't like to print more than that because I don't like to put a brim on here. When you put a brim, it leaves an edge, and I don't like to clean it up. This probably in your printer software is going to show it as technically unstable, even though it's flat on the surface. As long as you're not printing too many and you have a reasonably good bed, you should be able to get away without a brim. It's so much better if you do, because it'll save you a lot of cleanup. The whole point of doing this method is so that these things auto fit, and you don't have to have a bunch of expensive tools, and you don't have to do a bunch of sanding. So highly recommend that you fine tune this, get one to fit perfectly, and then print them in small batches until you filled up your fretboard. So if I have 18 frets, I'd have to do 6 sets of these of 3 on my printer. But if you have a really good adhesion on your bed and you trust that your printer is going to hold these things down, then go ahead and feel free. You can go all the way up to, if you had 18 frets, you can generate 18. Oops. Take a second to generate here. So you could transfer this whole STL, and those are all going to be on the same plate. But like I said, I find if one of these things slips, it's going to throw all of them off. So you're better off printing in small batches. If you want to draw a nut for the very front of your guitar, you are going to want to increase the height, because the first nut 0 is going to want to be higher than whatever your fret height is. So let me just show you. If I was going to actually print these, I would just go over here, File, Export STL, and drag it into my software. But say you wanted your nut 0 to be different, this also has the capability of doing that. If I change this to a 0 and I hit F6, you're going to see that it drew the fret, but it also put slots in here. Now you will still want to file these so that it comes to a point in the center. I just put a cylinder across here to mark the positions, but you can increase the width of this fret side to side so it sits flat on your guitar. You're going to increase the height, and you definitely want to go more than the standard. So I would recommend at least 1 millimeter higher, so something like that. And if I hit F6 or hit this button, you can see that it made it much taller, and it will still be the same width to fit in your slot in your fretboard, but this will raise it higher, which is what you want for that fret 0. If you want to make a bridge, you can use this same scenario for a bridge. Only the thing, if you were doing a bridge, then I would say that you want to make the width of this fret, way wider than your width that you were anticipating. You could make this out to 10 millimeters, and it will increase the width of this, and it'll be easier to set on the top of your guitar. And you will, if you use this as a bridge, once again, this top part, you do want to file this a little more so it comes to a point, and you can round the point just a little tiny bit, but you want to vary as defined as you can, because all your mathematics of all your frets are based upon a single point. Although honestly, because the bridge would be floating, you could adjust forward or backward a little bit. So it's not essential as long as it's consistent, but I would probably put a little bit of a bevel, and you could even just bevel it up to the back and just make sure that that back line where this is, that would be your high point. That would be at the scale length position on your guitar. And if you want to change the number of strings, you're capable with this program to change the number of slots for strings. So let's just put it up to 5 strings, and I'll hit F6 and allow it evenly spaces them across, which is exactly what you want, and they're perfectly measured for you for where it would be in the slots at the nut of your guitar. This would also be spaced the same for your bridge of your guitar. So hopefully that's helpful. I've come over here to my Prusa slicer. I'm going to go ahead and import, and I'm going to import that model that we just created. Here's all those frets. Once again, I would recommend you don't try to print 20. I would recommend that you actually only print 3 at a time. So and you save your original, go ahead, and I would suggest that. But these are flat on the bed, but there's not a lot of width. So when I go ahead and slice this, it's going to say there's print stability. Honestly, if you're just printing a few and you've got good bed adhesion, you're good. I would not put brim on these. It's going to take way more cleanup work than it's worth to put a brim on. So stay away from that if you can. Only if it's absolutely necessary for your print bed would I do that. And so if you were gonna, if you have a great bed and you never have problems with stuff slipping, then you could print out all 18 frets with these parameters and have them printed out in 35 minutes. And then literally you just pop them in 5 minutes or less. You can probably have all 18 frets inserted into your guitar fretboard and you're ready to go, because these things are already like rounded, and if you cut your frets flat straight, it shows a lot, a lot of little lines here, but it actually is going to have a high point exactly where we want. So hopefully that's good. And then of course you just export it, take it over to your 3D printer, and you're good to go. Hope you enjoyed this video. If you could hit like and subscribe, that would go a long ways to help a small channel like mine. I really, really appreciate it. If you could do that right now, it'd be fantastic. This is the fretboard that we created. You can see I've got the 3D printed frets in. I've just double stuck tape down on the neck of this guitar. You can see where the future's going. I'm gonna have to put some tuner peg holes into a long stock here. You're gonna have to pocket out a little area over here. You're gonna build the box of the guitar, the body of the guitar, and then we're gonna string it up and we'll be ready to go. Hope you stay tuned, watch for the new additions coming out. If you're subscribed, you should see it soon.